Hello, this is Mrs. Taylor, and I'm going to show you how to solve a quadratic inequality graphically. In this case, we have an inequality that features less than, so you'll get to see how to interpret that as far as when you're graphing the solution. So the first thing we want to do when we solve quadratic inequalities graphically is we want to establish whether we're working with a conjunction or a disjunction. And so you've got to look at two things. First thing you look at is the inequality symbol. Well, in this case, it's less than. So when we are looking at inequalities that are less than in the context of a quadratic inequality, we're looking at the part of the parabola that's below the x-axis. Now, in addition to that, you also have to pay attention to the a value. In this inequality, the a value is 1. So a would be positive, greater than 0. And what that tells us is that the u, the parabola, will be going upward. So, if we imagine an x-axis passing through this parabola, the portion that would be below the x-axis is the u part, not the legs. And that means that you're working with a conjunction, because the u portion of your parabola corresponds with conjunction, because it's the part that travels between the x-intercepts. And so, knowing that it's less than and my a value is positive, I know that it's a conjunction. You have to look at those two things together. Alright, so once we have that established, we can move on to graphing the parabola. And so first I'm going to write the y-intercept. It's the c value if your expression is in standard form. So that would be y equals 6. The next thing I'm going to find is the vertex. To find the x value, you do opposite of b over 2a. And that's a decimal. It would be negative 3.5. And because we're working with a graph, and because this is a terminating decimal, I'm going to write it as negative 3.5. Normally you'd leave it as a fraction, negative 7 over 2. And then I'm going to plug that x value into the quadratic expression to find out the corresponding y value of my vertex. And so I'm going to use my calculator to do that. Negative 3.5 squared plus 7 times negative 3.5 plus 6. So entering it in my calculator exactly how I have it written. If I press enter, I get negative 6.25. And again, because this is a graph, decimals are easier to work with, but also because it's a terminating decimal. It's not irrational. It doesn't continue or repeat. We can leave it as a decimal. All right, the last thing I'm going to find is the zeros, or are the zeros. I'm going to try the x puzzle first. So I'm going to set the expression equal to 0. X puzzle. And there is a solution to this x puzzle, so I don't have to use the quadratic formula or completing the square. The solution is 6 and 1. So 0 would equal x plus 6 and x plus 1. And x would equal negative 6 and negative 1. So my zeros are negative 6 and negative 1. Alright, now that I've got all that information, I'm going to graph my parabola. And I'm going to plot the y-intercept at 6. And my vertex at negative 3.5, negative 6.25. Of course, I'm going to have to estimate. So negative 3.25 would be about there. So, excuse me, negative 3.5 would be about there. And negative 6.25. 1, 2, 3, 4, 5, 6. And then a fourth of the way would be about there. And then my zeros are at negative 1 and negative 6, which would be there. And then I'm going to imagine the axis of symmetry and reflect my y-intercept. 1, 2, 3 and a half. Half, 1, 2, 3. Let's be about there. So now I've got plenty of points to draw my parabola. Now, that helps me present my answer, but that's not my final answer because I have to darken in a portion of the x-axis to represent the solution set. So we already established it's a conjunction, which means it's between the two intercepts. So I'm going to darken in the region between the two intercepts. The second thing I need to do is establish whether these intercepts should be closed or open circles. Well, they should be open circles because I have no equal to on my inequality. And because I'm working in marker, I'm going to have to use some white out to make them open. So, do that right quick. White that in. Whiten that in. And then make it obviously an open circle here, and an open circle there. And then I need to darken in between those two intercepts. So I will do that with a different color so it shows up on my graph. So I'm going to use orange. So graphically, I've just put my conjunction on the number line with two open circles to show that any x value between these two intercepts, between -6 and -1, if I plug it in, I'll get a true statement. However, if I plug in -1 or -6, I will not get a true statement. So that's how those bars there on the x-axis represent your solution set. This last part of my answer is to write this as an inequality. So I start with my lower intercept, my -6, because it's a conjunction. So I'm going to write it as one long inequality. So I write -6 is less than x, which is less than my larger x-intercept, which is -1. And I'm not using equal to's because I didn't have an equal to in my original inequality. So that would be my solution written out as an inequality, and this would be my solution graphically. And so that's how you would solve a quadratic inequality graphically.